Okay, well we have two more problems left, which are 63 and 66. So let's see what those are. Now this is a train problem. Use methods of example 8 or your own method to solve each problem. A train leaves Little Rock, Arkansas, travels north at 85 kilometers per hour. Another train leaves at the same time and travels south, so they're going in the opposite directions, at 95 kilometers per hour. How long will it take before they are 315 kilometers apart? Okay, so they've made up this table, and actually I'm going to make it slightly bigger. Make it this size, so I added one row. So we've got the first train, we got the second train, we got the total distance. They're just total. And then we have rate, which I guess I could have actually included as part of the table. Time, distance. So the relationship between rate, time, and distance. Rate is going to be, what are the units here? Kilometers per hour. Rate because it's something per time period. Time is hours. And distance is kilometers. So those are the units. So you can see if I take rate times time, so rate is kilometers per hour times time, which is hours, and then up to kilometers, which is the units for distance. So that seems to make sense, and that is true. Rate times time is distance. So all I have to do is I just have to take the first entry, multiply by the second entry, t, and I'll get a distance. So I get 85t as the distance. Now the second train is going the opposite way. It has 95 kilometers per hour, and it's going to travel the same amount of time, and it'll travel 95t. It says, how long will it take before they are 315 kilometers apart? So the total here is, the total distance is 315 kilometers. So this plus this has to equal that. The total distance is the sum of the individual distances. So our equation that comes out of this is 85t plus 95t is equal to 315. So we add this together, and we get 85 plus 95. It's 100. Well, it's 180. Why? Why did I get that? Well, if I increase this by 5 and decrease this by 5, I'm doing nothing. You know, add 5 to that, subtract. So it's like 90 plus 90. 9 plus 9 is 18. So it should be 180. T is equal to 315. So divide both sides by 180. And so you get T is equal to 315 divided by 180. I get 1.75 hours, or 1 3/4 hours, because 0.75 is equivalent to 0.75. If I didn't know that, how would I do it? Well, what you do is you multiply by, you create a fraction. So I'd multiply by 100 divided by 100. So that would be 75/100 as the fraction. And you can see each one of these is divisible by 5. So I divide the top by 5, and I would get 15, and the bottom by 5, and I get 20. They're still both divisible by 5. I divide that by 5, I get 3. I divide that by 5, I get 4. And there's my simplified fraction. So 0.75 is the same as 3/4. So it's 1 3/4 hours. You could say it's 1 hour 3/4 if you take 0.75 times 60. 0.75 times 60 is 45 minutes. Okay, so that's 63. 66, same kind of deal here, except that's not exactly the same thing. So they're going to leave someplace. You've got two people leaving. One person leaves a little bit later than the other. In this case, what's going to happen is the distance that they travel is going to be the same because it says at what time will they catch up. So the total distance, again, the distance is, if we go back to the previous problem, distance is rate times time. So let's say D sub one of these people's names, Jeff. The distance Jeff is going to be rate times time. So let's say X, well, we use T for the unknown time. So let's say T is equal to time for Jeff. Now, Joan leaves at 8 o'clock. So this is the time for Jeff. The time for, actually, they have to have the same initial. Let's put male and female here. So M and female. So the time Joan, since she leaves 30 minutes later, the time that she's traveling is going to be equal to the time that the male does minus 1/2, 30 minutes. Okay. So that's one thing we have. And then you have the total, these are going to be equal to each other. So the distance, Jeff, let's use M for male. So this is male. Okay. Really, in general, distance equals rate times time. So let's use the distance that Jeff is traveling is going to be equal to the rate, and he's averaging 5 miles per hour times the time, which is the temperature of the men. And the distance that, I'll use J again, just it's the male, this is the distance of the female, is going to be equal to her speed, which is going to have to be going faster. She's going 8 miles per hour, which is putting Jeff to shame, times the time for the female. Okay, well these are equal to each other because the distance, the time to meet up is when they both travel the same distance. So you get 5 times time for the male is equal to 8 times time for the female. But we can substitute here, the time for the female is going to be equal to the time for the male minus 1/2. So here we have, this is our algebraic equation. So you have 8Tm minus 4. 8 times 1/2. Half of 8 is 4. We're going to subtract 5. Actually, why don't we just, let's subtract 8. So let's subtract 8Tm from both sides. And we'll also add 4. No, we don't need to add 4 because that's already this side. So we just do that. These go to 0. This minus that, 0. So you get -3 time for the male is equal to -4. So to solve for the time, divide both sides by -3. And you get the time for the male being positive 4/3, which is 1 hour and 1/3 of an hour. 1/3 of an hour is 20 minutes. 1/3 of 60. So you get 1 hour and 20 minutes. So the time it's going to happen is just going to be whatever time Jeff left. So Jeff left at 7:30 a.m. Add 1 hour and 20 minutes. You're going to get The 1 hour will make it 8 hours, and 20 plus 30 minutes, hours of 50 minutes on the clock, which is 8:50 a.m. is the time that they will have traveled the same distance.